So now I'd like to work through a couple examples from this book, Piero Sraffa's Production of Commodities by Means of Commodities. And it's really an interesting text. It's almost, quite honestly, a grocery list of examples of linear algebra. So he begins by saying, consider a society where at the beginning of the year, they make exchanges between their two sectors of the economy. People that produce iron sell 12 tons to the wheat growers in exchange for 120 quarters of wheat. And the wheat growers make this swap at the beginning of the year. Then they keep working till the end of the year, and they produce 400 quarters of wheat, and the iron miners get 20 tons of iron. So Sraffa asked, what is the exchange rate for this society in order for it to keep producing itself? We see that there's no shortage, so 280 quarters of wheat and 120 quarters of wheat together add up to 400 quarters of wheat, exactly the amount produced. And 12 tons of iron plus 8 tons of iron is precisely 20 tons of iron. The inputs equal the outputs exactly. So the first step is to turn this into a system of linear equations. And we're basically trying to solve what the prices are going to be. 120 plus the value of 8 tons of iron is equal to the value of 20 tons of iron, right? That's equation 1 and 2. Now we can rewrite this using just basic arithmetic. Equation 1, if we subtract 280 quarters of wheat from both sides, or the value of 280 quarters of wheat from both sides, we end up with the value of 12 tons of iron is equal to the value of 120 quarters of wheat. So that's 1 prime. And now we can solve this for 1t is equal to 10w. So 1 ton of iron may be exchanged for 10 quarters of wheat. By the way, if you're wondering what a quarter of wheat is, because I was when I was reading this, it turns out that in England, since the Magna Carta was signed, a quarter was used to establish the units for grain and alcohol and a few other things. And it really refers to a quarter ton. Of course, a ton back then was a different amount of weight. So this is some weight of wheat is equal to some weight of iron, or maybe exchanged for it. Now, this might be a bit too convenient. The numbers work out just too nicely. But it turns out Sraffa shows that if you have any system where the inputs sum to equal the outputs for each sector, it works just fine. It's a little trickier with larger sectors, but it's just fine. And to prove this point, Sraffa then gives another example where there's 3 sectors, wheat, iron, and pigs. And if you look, the total amount of wheat needed as input is precisely 450 quarters of wheat. The total tonnage of iron needed is precisely 21 tons, and there's only 60 pigs in this economy. So, again, I'm not defending the realism of this particular model. I'm not sure 60 pigs suffices for an economy, but I don't know. I'm not a pig farmer or an economist. Now we can transform this system of equations to describe the prices. So 240 W, the value of 240 quarters of wheat, plus the value of 12 tons of iron, plus the value of 18 pigs is equal to the value of 450 quarters of wheat. Similarly, value of 90 quarters of wheat plus the value of 6 tons of iron plus value of 12 pigs is equal to 21, the value of 21 tons of iron, value of 120 quarters of wheat plus the value of 3 tons of iron plus the value of 30 pigs is equal to the value of 60 pigs. So these are our first three equations. And we can rewrite it by subtracting the inputs from both from the sector. That is to say, we subtract 240 quarters of wheat, the value of it, from the amount produced, the value of the amount produced. So it's precisely then relating the amount of the value of the inputs from other sectors. Wheat sector needs must be equal to the amount produced by the wheat sector that is not used in the wheat sector. So that is to say you have 12 tons, the value of 12 tons iron plus the value of 18 pigs is equal to the value of 210 quarters of wheat. And we can do likewise with the iron sector. 90 quarters, the value of 90 quarters of wheat plus 0 tons plus the value of 12 pigs is equal to the value of 15 tons of iron. And then for the pig sector, the value of 120 quarters of wheat plus the value of 3 tons of iron is equal to the value of 30 pigs. This is, in some sense, the seller's perspective, the producer's perspective, what they need to set the value to in order for this economy to keep going. And we can pick any of these economies to eliminate one of the variables. For example, we can use the pig producer's economy to figure out that the value of 3 tons is equal to the value of 30 pigs minus 120 quarters of wheat. And then we could use that in the wheat growers sector. So then 12 is 4 times 3. So then 4 times the value of 3 tons of iron plus, so that would be the 12 tons, the 18 pigs is equal to 210 quarters of wheat. So what now? We can actually multiply this out and we find, 4 times 30 is 120. 120 plus 18 is 138. The value of 138 pigs is equal to, 210 plus 4 times 120 is 480, which is 690. We find that this is equal to 690 quarters of wheat. And this might seem bad because these don't look like nice numbers, but actually 138 times 5 is in fact 690. So that means that we have one pig, the value of one pig is precisely the value of 5 quarters of wheat. So that's one exchange relation down. Now we need to figure out what a ton of iron is exchanged for. So we can go back to equation 2 prime and plug in how much a pig is valued in terms of wheat. And we find that 90 quarters of wheat plus 12 times 5, the value of 5 quarters of wheat, is equal to the value of 15 tons of iron. In equation 6, 12 times 5 is 60. 60 plus 190 is 150. So the value of 150 quarters of wheat is equal to the value of 15 tons of iron. That's precisely just doing arithmetic on equation number 6. And this means that the value of 1 ton of iron is equal to the value of 10 quarters of wheat, and that's equal to the value of 2 pigs. And that is what the producers must set their values to in order for this system to work. And we didn't cheat, we just used linear algebra. This might be a bit perplexing because all the inputs had to equal precisely the outputs, right? The column of inputs of wheat summed up to precisely the amount produced of wheat. Similarly, the inputs of iron for every sector sum to precisely the output of iron. And likewise, the total number of pigs used as inputs is equal to the number of pigs produced. The more realistic situation is that there's a surplus. We don't know how many pigs are going to be needed each year, so we need at least 60 pigs, sometimes more. Likewise, we don't know how many tonnage of iron is going to be needed for inputs, so we just try to make more than what's needed. And when you do this, well, Sraffa does this in the rest of his book, you end up introducing a surplus, and that's equivalent to introducing a rate of profit. I can go into this in greater detail later, but we will need to introduce some concepts in linear algebra first before we can continue looking at Sraffa's book as inspiration for linear algebra. But this is just one example of how to use linear algebra to solve actual real-world problems.